So a few months back, I accidentally laid my scooter down. It wasn't that hard, you know, but after that happened, I started experiencing starting problem with my scooter, you know. There can be many things that can avoid a scooter from starting, you know. You need the main three things that you need for a scooter to run is fuel, spark, and compression. But if you're sure that you're getting fuel and you're getting spark, your CDI is good condition, I mean, you're completely sure everything is fine, but when you try to start the scooter, like I'm gonna do now, when you press down the switch, all you hear is a click. See? Coming from this relay. And sometimes you can get the scooter running and sometimes it doesn't work. I'm gonna show you in this video how to check for that. It's most likely something with the relay, with the starter motor relay, or with your actual starter motor right there. It can be a bad connection, it can be dirty inside, it can get faulty, or your actual relay can fail, or there can be something in between the connection that is not allowing to pass the current very well. Usually the most common problem for that is a weak battery, but if you're sure you got a nice new battery, it's fully charged, your terminals are clean, and you know that your terminals in the relay are also clean. Have you tested the relay? I'm gonna show you how to do all those things in this video, but it's most likely that my starter motor is dirty or it went bad. So there's a way you can clean it up and fix it, or you can just buy a new one and, you know, spend 300 bucks, which is not the idea. So we're gonna attempt today and we're gonna try to fix that problem. So let's get into it. So here are the tools you're gonna need. All you're gonna need is a Phillips screwdriver, a flathead screwdriver. You're also gonna need a 10mm wrench, 8mm socket, a long one and a small one. We got two sizes, a 10mm socket, a small wrench for our socket with the corresponding extension. You're also gonna need some terminal grease, some regular grease or any type of grease you have available, some metal brush to clean all terminals. You're gonna need a multimeter. It's always recommended to have some safety goggles because we're gonna be spraying some cleaners, and so you wanna always protect safety first. A pair of just clippers, so I don't know how you call those, not sure. A ruler or a set of calipers if you have that in hand, but any ruler just works. Some clippers, some needle nose pliers. Obviously we're gonna need our tool to remove the barriero to be able to get to that bendix and clean it up if we need to. You're also gonna need the holding clutch tool, and if you don't have this tool, you can click on that video right there so you can see that quick tip. You're also gonna need some wires, a fully charged battery, 12 volt, also some electrical cleaner for electrical parts. You're also gonna need a sandpaper, a 600 sandpaper, anti-oxide sandpaper, a power drill, 18mm socket and a 19mm socket too, those two. You're also gonna need some big wrenches like this one, and you can also have in hand some brake cleaner to clean the bendix itself. And that's it. That's basically all the tools you're gonna need, so let's get into it. Okay, so the first thing we're gonna do is we're gonna check our battery, see if our battery is weak or if it is fully charged, because that could be as simple as that. So we got 12 volts. If you got like below 12, like you got 11.5 or 11.8, or it's like under 12, you really have a weak battery. So the next thing we want to try is we're gonna try to run the scooter, the starter motor actually, but you want to put your ground wire here, the positive into the where it connects. There's a little rubber cap here, and you want to try to pull that off. And when you try to run the scooter, turn your key over. And when you try to press down that switch, make sure you got it into the ground. And when you try to run that, you should get the same as the battery. If you're not getting the same voltage as your battery, there might be something in between the relay or the starter motor in between. See? I don't think there is anything in between the relay and the battery. So any reading, there is for sure something in between the connectors of the relay and the starter motor. You probably may have to take the wiring harness out to see if there's a cable caught up in the way, or you know, any cable burn off, or you know, but we're looking so far so good. So the next thing you want to test out to see if not the battery. If you're having a weak connection and you're sure your battery is fully charged, I'll recommend brushing your terminals, so just to make sure and be sure everything is nice and clean. So you want to take it off, you know, disconnect your battery, clean the terminals with a wire brush, apply some terminal grease, always recommended, and everything's making good contact. The next thing I'm gonna try here is we're gonna check our relay to see if it's fully working or is a faulty relay, because it could also be as simple as getting a new relay. So we're gonna proceed and remove these screws right here, and we're gonna remove this cap so we can get access to that relay. So once we have removed this plastic top here, you can proceed and pull this out carefully. You don't want to, cut the cables in the way, and then you want to remove your relay. We're gonna proceed and test that out and get this out of the way. Okay, so we're not gonna test our relay. Here is the relay. So you wanna have a fully charged battery, connect to cables, negative and positive, and you wanna plug the positive into the number 85 over there. Put that cable there slightly temporarily, and when you put the black one, you should hear a click. See? But we want to measure if we got some resistance there, because if we don't have any resistance, then it's not working. So you want to set your multimeter into ohms, and then you want to, in the 87 and number 30, you want to put the black leaf in number 30 and the red one on the top. It doesn't matter which each one is, so you want to hold those two, and it's going to be a little tricky with one hand. And then once you have those in there, you want to plug the black one into here, and we should see some resistance here in the multimeter. As you can see, we got something there. See, this is a fully working relay. You should be fine in this way. That's it. So it's not faulty, it's a fully working relay, and we're gonna just leave it in there and keep our weight down. So at this point, there's two things left that it can be hacked. The first one, your starter motor is not engaging the brushes, and there might be dirt or carbon inside. It's really dirty. This is a pretty old scooter. It's from 2002, so you can expect that pretty easily. So we're gonna attempt to clean it up if it's that the problem. But the other thing that it could be happening is your bendix, what they call the starter clutch or the bendix, is most likely getting stuck and not engaging with the motor. If you can hear the motor run, starter motor, run when you press down the switch, if you hear the motor is trying but it's not engaging, so you want to take your CVT cover out, and we're gonna take that bendix out of the way and clean it up, because it's most likely getting stuck because it got old oil or residues from the belt, and you're all there, and it's just getting stuck and it's not engaging into the barrier to run the scooter. So okay, so we're gonna proceed and remove the CVT cover so we can get access to the little bendix that we're also gonna be fixing. So once you have gained access to the CVT cover, we are not going to be touching nothing here into the clutch. We just need to take this little gear out. This is the actual bendix. If you don't have the right tools to do this, and you just want to check if this is not the problem, it's not getting stuck, you can see how it's free play. You can check it without taking it out, so you can spin this and you see how it spins freely. If yours getting stuck, I'll recommend going through the cleaning. It's just removing this piece, taking it out. You don't even have to take the whole thing apart. You just like open it up, clean it up, with a hair compressor, go over, make it nice and clean, put it back on, and it should be good to go. You can just pick out your bendix. Some people call it the starter clutch, and some people call it the bendix. I don't know which one is the right one, but this one seems to be working pretty fine. We're just gonna give it a nice clean because since corroded, just with some brake cleaner should be good to go. But at this point, I'm already sure it's the starter motor. You don't hear the motor running. It's most likely that, so we're gonna proceed and take that motor out of there and show you how to clean it up. Let's get into it. So the first thing you wanna do is you wanna disconnect your air filter hose so you have more clearance and more room to work. So obviously, before you start disassembling your starter motor, you wanna disconnect your battery. Then once you have removed this hose out of the way, you can see the actual motor in here. What you're gonna find here is 3 bolts. There is this one right here, where you can just remove this hood out of the way here. Then after you have disconnected the battery, make sure you disconnect your battery with a 10mm wrench. You want to unbolt that. So these are the two bolts that you need to unscrew. This one right here and this one right here. And this is the one that connects the cable. So this one on the bottom, the bolt right there. Now this is screw, this bolt right here and this one right here. And with a small socket with the 8mm wrench, you know, the small one, you can get access. Then after you have removed your two bolts, you're ready to pull out the motor itself. All you gotta do is you just gotta, you know, twist it from one side to the other like this. Juggle it around. It will eventually pop out. There we go. Got our starter motor out. It's that simple. So we're gonna proceed and open that up, cleaning it out. To disassemble it, you just gotta unscrew these two fasteners right here and open it up. If you don't know what you're doing, I'll recommend taking this to an expert, an electrician shop or something. So if you're not familiar with this stuff, so don't play with it because you can end up breaking it and you're probably gonna need to spend $300 to buy a new this one. So just be careful. If you wanna experiment, that's why I'm making this video, so you can easily fix it by yourself at home with basic tools. So let's get into this thing and clean it up. We're gonna bring our motor and we're gonna proceed and unscrew these two fasteners right here. So I'm gonna use a 7mm socket to unscrew these two fasteners. The thing is, because those screws are pretty soft. Be careful with that O-ring there, you don't lose that O-ring. Make sure you don't lose these O-rings, they're pretty critical, you don't lose them. So you want to remove that little piece. You can see here's the problem. You see how bad that is, really bad. So we're gonna proceed and sand that down, and that's really our problem right there. It's really bad. You cannot even see the copper right there. That's crazy. So we put this in a side. You want to separate these two pieces, make you lose that O-ring. Make sure you don't lose this one, pretty critical too. Here's where our magnet is. We're gonna clean all that, and here are our brushes. These are the two things that we're gonna be sanding down, these brushes and the copper right here. See, these are like spring loaded. We're gonna be sanding down the end of these two brushes slightly, carefully, as well as this one. So let's proceed and do that. Okay, once you have disassembled the rotor itself, the next thing you want to do, you want to unscrew these two fasteners right here, so you can take this plate out. So when it's time to reassemble everything, it's more easier because it's pretty tricky to get everything together with the magnets. So you want to be careful. In my case, you can see that nut got really stuck, so you want to remove the nut first. Remove this nut. You got this rubber piece and this O-ring right here. See the O-ring, this one right here and this piece right here. And you just can remove the plate out of it and push it out carefully, but mine popped out before. You want to take those out carefully. You want to be careful with this one. We're gonna be measuring the size of these brushes. They should be between, you know, 8, 9. Those are, if it's under 7, it's more likely you will need to replace these pieces or the whole thing if you want to. But we're gonna be sanding down the end of it, of both, so, and cleaning the whole thing so it's not pretty messy, you know. Sometimes you have a ball bearing inside here, but I didn't see it on this one. I don't know if it's inside here. I don't see it. I don't think this one got one. So the only thing you get here is this washer right there. It probably got stuck in here into this plate, or you can just take it out from here. And this has all the pieces. Make sure you don't lose any of those. The little O-rings, screw the washer, make sure you don't lose them. And we're gonna proceed to clean them up with electrical cleaner. And you're also gonna need a Sandpaper 600. That's all you're gonna need to be able to sand this down and get that copper back. But first, we're gonna test with the multimeter to see if everything is working perfectly. So let's get into that. Okay, so once we have disassembled the whole starter motor and we got the rotor out and everything, next thing you want to do is you want to check your rotor to see if you have any ground leakage or if there is any bad connection between the segments and the commuter. So we're gonna test that with the multimeter. So what you want to do, I find out the easiest way to do that is to grab this middle plate and place the one here in the top like this, like if you're gonna assemble the whole thing, and then you're gonna proceed and introduce this in here so you don't have any bad ground connection or anything, so we can work comfortably. Well, you know, we got our multimeter here. Turn your multimeter into 200 kilo ohms right here. And what you want to do, the first thing that we're gonna test is to see if we have any ground leakage in the circuit here with the commuter. So what you're gonna do is you want to put the black lead, this one, the black one here on the top. So once you put it there, you want to go ahead and go all around each of the segments, all around the commuter, to see if we have any ground leakage. Got nothing there, nothing there, nothing there. Looks like we're good to go. So the next thing that we're gonna check is to see if we have any open circuit in between any of the commuter segments of each one. So the way you test that is you put the black leaf in one of the segments without touching the rotor at all, and then you go and touch each of the segments all around without moving this one from there. And you just put that one in there, and you should see the multimeter move, goes to 0. Good, good, that's good. Pretty much good to go. And next thing we're gonna do is we're gonna proceed and clean this up with some electrical cleaner. You want to open up those gaps. It's about 0.2 millimeters. It's not something that you need to measure, but just by eye, you know, by proximity, you just can get a little flat screwdriver and, you know, try to open those up a little more. We're gonna proceed and do that and sand down this very uniformly. We're gonna use a power drill, put it here and just spin it around so we can sand that down the best we can. It looks really, really bad. That's why it's probably not working pretty well. So let's proceed and do that. Okay, so the next thing we need to do is check our brushes. These are the ones that make contact into the commuter. They are spring loaded here into this two little slot. You can just remove them like that. It goes into the little slot. We remove that one from there, and then you can remove this one from there so you can measure it. These are the ones that make contact in here when this is spinning. It goes like this. It'll go spring loaded, and they make contact there, and this is spin. And this is why probably we don't know having a good contact there, because, you know, it's very bad and corroded. But you also want to measure, you know, the service limit of these brushes, which is about 9 millimeters. That's the service limit for these brushes. You can measure the distance here with a caliper, with a set of caliper, but you can get also away with a ruler. We got a ruler here. We can put our brush right next to it, and it should be about 9 millimeters. If it's under that, that should be our problem right there. So you can see there is 1, 2, 3, 4, 5, 6, 7, 8, 9. We're over 9 millimeters, so we're good to go with this one as well as this one. This one seems a little less, but it seems to be still good to go. This one can still keep working. If not, you can buy these separately, use the brushes and install them separately, but it doesn't seem that we need to do that. They seem to be good enough. 5, 6, 7, 8, 9, 10. They're just over 9. If you're below 9, I recommend replacing. But we're gonna be sanding down. See, we're gonna break that glaze in here a little bit, sand that down just slightly so we get some good contact back in this plate. And we're also gonna just spray electrical cleaner all over the part and get them all ready for install and give it a shot. So we're looking good so far, so good. Okay, so we're gonna proceed and clean all these parts. These ones, the caps, mostly where the magnets are and all these caps, we're gonna proceed and remove the O-ring, because we're gonna be cleaning these ones with brake cleaner. But most importantly, the electrical parts, like these ones, you wanna clean those with electrical cleaner. One of these ones, very important. First, you wanna remove this O-ring, because you don't wanna spray brake cleaner onto that O-ring right there. So just remove that one, and we're pretty much ready to. You wanna remove that one too over there. This O-ring, very important. Make sure we don't have any O-rings in there. Got that washer there too. Make sure you don't lose that one. It's a pretty thin washer. Washer. Make sure you don't lose that. So, and after we clean them up nicely with some brake cleaner, you know, slightly, so we remove all the dust from it. Seems to be pretty clean. Nothing too crazy, just to get the dirt out of it. Okay, then we're gonna clean up the rotor and the commuter itself. You're gonna need a toothbrush or anything like plastic, not too hard, and we're gonna use the brake cleaner. Okay, so we give it a nice clean, then we're ready to sand it down and clean it again. Then we can grab our brushes. Make sure this is nice and dry, and then we're ready to sand that down very nicely. Maybe you can go with the brush a little bit. It's nice and clean. See how we clean that up. What you want to do here is you want to grab sandpaper. You want to measure just slightly the width. We're going to be working on it. You just want to cut a piece with that width over there. So I'm going to make a mark there. I'll go over with the sandpaper like this, very uniformly all around it. So what we're gonna do is we're gonna take out our driller, if you have a driller in hand. And what you want to do is if you got one that can open up all the way so you can fit this in there, see if you have one that can fit this tip in there, that will be good. And proceed and take that in there so we can spin our motor. So what you want to do is you want to grab your sandpaper with one hand like this, and with the drill that's what we want to get the copper back. You want to get rid of the whole mark. You don't want to stop sanding down until you don't see no marks all around it. You can see we still have a little bit. So as you see, you want to get rid of all those marks. See those marks? Yeah. And that's what we want to get at the end. See? Now let's proceed and clean it up. Take it off from the drill. You want to go over from the top and remove all the residues. And probably with a thin screwdriver, you want to open up the groove there. Something you get pretty thin, maybe one of those things for camping there. Make sure these are nice and open. I'll recommend putting it on the drill like this so it dries. And this is how it should look at the end. See how it looks brand new again. We remove all that burn carbon from the copper and we bring that copper back out with the sandpaper. You can see we open up the groove between each of the segments. Everything is nice and shiny now. Should be good to go now. Now we're gonna start cleaning our brushes. We already cleaned it up and we're gonna give it a nice sand down here at the end just slightly so we got some good contact here into our new copper. It looks like brand new. This is how it should look at the end. It should run. I'm more than sure this is gonna run perfectly now. So let's clean out the brushes and get it ready for a sample. With the brushes, it's pretty simple. You just gotta sand down. You see how it have like a rounded part? Try to keep that shape. Don't try to get rid of that. So you just wanna go like that. Just scuff them a little bit so we get that carbon out of the way. Not too much, slightly like that. So we make some good contact back into our commuter. And we are now pretty much ready to start assembling everything back on. And let's get ready for that. Remember to put our O-rings where they were. Very important to put those O-rings back in place. Make sure this one goes into the right direction. The O-ring in there. You gotta put a tiny bit of grease in this end inside there so we get into that little push there. Good enough. I think the best way to do this, facing to the top, so you want to open up your brushes with your nails like this. There we go. We're now in place. Then you can put this washer in. Then you can put this washer in there. And then the next thing you want to do is you want to grab this plastic one. It goes in just in one direction like this, and this goes like this. So you want to put the screw in first like here. See what I'm doing? Put it in there. Make sure that washer is in place with the pivot. Slide it in, and there you go. Put our two screws back in. Make sure the holes are lined up. Tight down pretty well. You can see our rotor move freely in there. And then the next thing you want to do, you want to grab this screw, put this little O-ring in that direction. It's like a flat part, and then in the rounded part, and you see the gap, that groove. You gotta go on top of that groove. Make sure you grab the screw with your finger while you pull down, because you don't want to offset it from the place you put it. Slide that all the way down into that groove. Set that in there very nicely in place. Then you got this one that goes in this direction, and the knob. Tie that down pretty well with your wrench. You want to be careful and you don't want to turn this over because you can see it spin freely. And then we're gonna proceed and slide this back in. Make sure the part that where the O-ring is goes inside first, or this is where you want to be careful with it, because you don't want to set that off place, and you want to make sure you line up these two gaps with the screws that are gonna be in these two holes right here. It goes in this direction like this, where the holes are. See, you're gonna make sure you grab this with your fingers. It's gonna tend to pop, so you want to hold it down. There we go. Make sure you put this in the right direction. We have clearance for screws that goes in those two slots. Make sure we got clearance. See? And then we can proceed and put this washer back in place. This one goes in here, so you want to put the holes right in there. Maybe you can pass one of the screws first. So you see how the screws goes with the magnet into one side to the other, so you want to hold it with your finger pretty tightly underneath there before you twist the thing. Actually it goes into one position, so make sure you got that one in place. Sure everything is nice and tight. So if you take fully charged battery, and then we got the motor here, I'm just gonna put my feet on it. It's just the brute way. So I'm just gonna try to see if the motor runs after the repair. And there we go. Works perfectly. There we go. Seems to be working fine. Really neat. And get it ready to install into the scooter. Perfect. Good thing to do, grab a brush, a wire brush, brush these terminals, all the terminals. We're gonna be brushing all the terminals from the battery, from the ground of the bike, so we're sure we're having a good connection in all the terminals. We also want to apply a little bit of terminal grease in here. After checking all the terminals and sanding down with a brush, putting some of the terminal grease, we check all the ground cables, which I believe it was my problem, because I test the voltage on the battery was good. Then I test the voltage on the relay, and it was the same. Then I test the voltage on the starter motor, and I was getting voltage there. So I removed the starter motor, I cleaned it up, and when I test the motor out of the scooter with a battery, the actual motor was working. But when I swap it on into the scooter, it wasn't working. I did check like literally everything. I went over all, checking the relay, the battery, everything. I did all the steps, and ended up being that the ground cable underneath the CVT cover was loose. So all because, I don't know, it got just loose by the vibration. So that's why you first want to check your ground cables before anything. So let's give it a shot. Perfect.